Okay, so this application for differentiation is has a lot of similarity to a chord job. So in chord job, we usually use this gradient formula. So in this application, we are going to be using dy dx. So we are going to be using dy dx as a gradient formula. So there's a lot of name for dy dx. It's called the gradient function. It can be called the gradient formula. It can also be called the gradient of tangent. And it can also be called a gradient of curve. So there's just a lot of name, but they are all pointing back to dy dx. Okay, so there will be some component that looks like AMF chord job. Okay, so in this application, we are investigating the equations of tangents and normal. So if you recall, tangents are something like this. Okay, so for example, in this example here, example 1. Okay, so if you got a curve, okay, you just locate the point. So in EMAF, you draw tangent. So you draw tangent with your ruler. So the tangent that you draw is a straight line. That's why it will always be a mx plus c format. Okay, so no, it will always be a straight line for equation of tangent. Okay, and then so if you look at the format, you need a mx plus c. M is the gradient, but right now I'm going to be using dy dx, the gradient formula. So I'm using my dy dx. So this is the formula that I'm going to be calculating gradient. Okay, but it will just be a formula until you substitute in the x. So in this question, right, you should sub the x equal to 2. So it will not become the value of m yet until you sub in the value of x. So it will just be a gradient formula. So you sub the x value, you got the dy dx, 8 minus 3 is 5. So that means, right, the gradient is 5. So here the gradient is 5 and it passes through this point. So with the gradient and a coordinate, so your mx plus c will be something like this. So that's why this part behave a lot like chord job. So that is the equation of tangent. Okay, so the steps are quite simple. One of the common mistake will be sometimes some students forget to sub the x value. Okay, so in the next example, we're going to explore the idea of a normal. So normal is a straight line that is perpendicular to the tangent. So it again is a straight line. That's why it will still be a mx plus c. Okay, so I'm going to draw for you the graphical idea. So a tangent will always brush past the curve. So at the point of contact, you can have another line that is perpendicular. So this one will be the normal. So from the graphical idea, we know that tangent will always be perpendicular to normal. And if you recall your chord job, the gradient, there's a formula for perpendicular line. So in your chord job, it was m1 times m2 equal to -1. So that is the formula responsible for perpendicular gradient. So right now we also have this. So this part will be a dy dx. So this can be a formula. So this is a formula that link the gradient of tangent and the gradient of normal. Okay, so if you want to simplify a bit more, that means, right, if you want the gradient of normal, it will be -1 over dy dx. Okay, so I'm going to show you in an example. Okay, so this one is an equation of normal at the curve at x equal to 1. If you want to, you can just draw a little bit first. Okay, usually I just draw a random. So this part here is the tangent. Okay, and this coordinate is 1 something. Actually, of course, you can find the y coordinate. So I'm interested in the normal. I dot the tangent to remind myself that I didn't want the tangent. So I would like the normal. Okay, so we go through the same procedure. You do your dy dx. And don't forget to sub in the x. When you sub in the x, that will be the gradient of tangent. So don't forget, this is the gradient of tangent. It's not your gradient of normal yet. So apply the formula. So gradient of the normal will be -1 over gradient of tangent. And, okay, so right now I already gotten the gradient. So the gradient is -1 over 9. But my coordinate is missing. So as with the idea of chord job, if you would like the equation, you must have a full coordinate. So I'm going to find the coordinate first by putting into the equation of the curve. So from here, I got a coordinate and a gradient of -1 over 9. Then I can perform my mx plus c. So that's it. That is the generic idea. So these two is just showing you how to find equation of tangent and how do you find the equation of normal. So if you follow strictly to the rules or to the steps, it's actually not very difficult. Okay, common mistake sometimes will be like for the gradient of normal, some people forget the steps. So they forget the step on this part. Okay, or sometimes they differentiate wrongly. So because sometimes they give you the curve that can be, you will need your quotient rule or your product rule. So if you got careless in your dy dx, then obviously everything is careless. Okay, and then obviously there are some extension questions. So there will still be some examples. Okay, I'm going to show you example 3 first to show that it's actually an extension of the tangent. Okay, so right now the question actually kind of gave the equation. This is the tangent. And the equation is given. So this is the equation of tangent. And it is in the mx plus c form. So my job is to find why is this a. So it's actually opposite idea. Okay, so how am I going to do that? Okay, so first of all, when I look at the tangent, I realize that the m is 4. So the gradient of tangent is 4. So I think just now I mentioned one of the keyword is the gradient of tangent is actually your dy dx. Okay, and then from the curve, you'll have the curve. From the curve, I will manage to get my dy dx. So in this way, if I combine these two, I will be able to get the x coordinate of A. Okay, so if I would like the y coordinate of A, do I return it to the tangent or do I return it to the curve? So because the tangent has an unknown, so I will return the x equal to 2 to the curve. So I will get the y coordinate. So A is equal to 2, 2. So in fact, if you have already found your coordinate of A, it's a bit like your chord job already. So put back the coordinate of A into the tangent equation. So you will find the value of C. So this one is still not very difficult, okay, but you actually need to realize that the gradient of tangent is divided, or else you will get stuck. So this is one of the things, if you don't get into your head that dy dx is representing the gradient of tangent, gradient of curve, or gradient of graph, whichever phrasing that they are phrasing, you will find that you can't make use of dy dx. Okay, so there are more examples to show you. These are the quite basic ones.